first we will initially collect the data from the question. In a linear elastic spring as shown in the figure, when a load of 10 kN is applied and the deformation is observed to be 20 mm, and when the load of 20 kN is applied and the deformation is observed to be 35 mm, we have to calculate the stiffness of the spring. So if you see the diagrammatically the above problem, this is a spring and a load of without any load. If the same spring subjected to a load of 10 kN and we observe a deflection of 20 mm. So in a similar way, when we observe kilonewtons, the deflection is observed to be 35 mm. So here we have to calculate the stiffness K of, let me represent it as K, stiffness of the spring. So stiffness is equal to P2 minus P1 by U2 minus U1. Here this is P1 and let me take it as P2. This is U1 and we will take it as U2. So by substituting the values, P2 is 20 minus 10 divided by 35 minus 20, that implies 10 by 15. We will get it as 0.67 kilonewton per millimeter. So option A is correct. Here the question is, from the following data of a bridge is to be constructed across the river. So by using this following data, the bridge has to be constructed over a river. The catchment area is given as 600 hectares and the maximum intensity of rainfall for that particular area is given as 1 centimeter per hour and the runoff coefficient is 60%, permissible velocity is 120 centimeters per second. Average depth of flow is given as 180 centimeters. So what we have to find out is the maximum flood discharge. Maximum flood discharge, that is Q is equal to AIP by 36, where A is the area of catchment, I is the maximum intensity of rainfall and P is the coefficient of runoff. So area is 600 hectares, I is intensity of rainfall is 1 centimeter per hour and P is runoff coefficient is 0.6 divided by 36. As it is an empirical formula, this 36 is conversion factor into meters SI units, that is into a single unit, that is meter cube, and it is going to be in terms of centimeters per hour and it has to be in hectares. Then the equation will result the value in terms of cubic meters per second, that is 10 cubic meters per second. 10 cubic meters per second, option D is correct. We have to calculate the linear waterway required for the bridge, that is linear waterway required for the bridge, that is this thing we have to find out, linear waterway. So if it is considered as D, then L into D is going to be the area of the entire catchment. So if you take Q is equal to AV, we know, right, where waterway or area is equal to Q by V, that is Q we know the discharge from the previous question, that is 10 cubic meters per second, and velocity V is given as permissible velocity, that is 1.2 meters per second. Therefore waterway A is equal to 8.33 square meter, right, linear waterway. This is what we have to find out, is equal to area by depth of flow or average depth of flow, that is equal to 8.33 divided by 1.8 meters is equal to 4.63 meters. 4.63 meters, option C is correct. E is given as a 6 meter high retaining wall is supported a soil of unit weight and angle of internal friction of the same soil and cohesion of the soil is given. So we have to determine the Rankine active force per unit length of the wall after tension crack occurs or developed. So depth of tension crack, we know that 2C by gamma root Ka. What is Ka? Activate pressure coefficient. It is going to be tan square 45 minus 5 by 2 or 1 minus sin 5 by 1 plus sin 5. By substituting the angle of internal friction value, that is 26 degrees, that is given in the question, we will get the coefficient, activate pressure coefficient as 0.39. So root Ka is going to be 0.625. Therefore, the ZC, depth of tension crack, is 2 into 14.36. Cohesion value is given and gamma is 17.4. Root Ka value is 0.625, that is equal to 2.64 meters. The depth of tension crack we know. Now the Rankine active force per unit length. We have to calculate the Rankine active force, that is half H minus depth of tension crack into gamma H Ka minus 2C root Ka, that is equal to half H is 6 meters minus ZC is 2.64, gamma is 17.4, H is 6 meters into Ka is 0.39 minus 2C is given as 14.36, root K is 0.625. Therefore, we will get the value of 38.25 kilonewtons per meter. 38.25, that is 38.2 approximately. So option A is correct. Question is, determine the line of action of the resultant after developing the tension crack. We know the tension ZC, that is depth of tensile crack, is 2.64 meters from the previous question, and H is equal to 6 meters, that is given. So the force is going to act 6 meters. This is 2.64 meters. The remaining, this height is going to be H minus ZC, that is 6 minus 2.64 is equal to how much? 3.36 meters. So the resultant force for a triangle Z bar is equal to H minus ZC divided by 3, that is 3.36 divided by 3, 1.12 meters. 1.12 meters, option C is correct.